Hello, welcome to Parametric House. In this Grasshopper tutorial, we want to model a space frame structure on a base surface. So we're going to basically use a surface like this to get started. Then I'm going to divide it into a series of U count and V count. As you can see here, I can change the number of divisions, and also I can change the height of the truss, as you can see here. Be sure to watch the video till the end, because we're going to talk about some techniques which you can visualize it fast. As you can see, it's really fast as I'm changing the U count and the V count. So I'm going to teach the visualization technique at the end of this tutorial. Okay, to get started from scratch, what I want to do is to draw a base surface. I'm going to use the 4-point surface here, open the menu, and use this rectangular plane to make the base surface. And then I'm going to deform it to bring it up a little bit to make it for the base surface of the parametric space frame. Because the U and V, the number of the UV division, especially when you are in the shaded mode, is like by default 1 by 1, I'm going to click on the surface and say rebuild. So the rebuild command is going to help you to add up the U and the V count. I'm going to select this, rebuild, and as you can see, by default it's 2 and 2, and I'm going to increase that to 20 to 20, and the degree, which is like 1 is for line, 2 is for arc, and 3 is for NURBS. We're going to increase that from 1 to 3. We can also delete the input so we don't get the base NURBS surface after we rebuilded the base surface. Okay, now you can see that the number of the UV count is increased. We can use a simple command called soft edit surface, which you can type soft and find it here. This tool is great if you want to just deform a base surface based on a point in the normal direction. As you can see, it's going to deform that surface in the normal direction, and the distance for the deformation is U and V distance. For example, if I want to deform it, and by the way, you can also fix the edges if you want to. For example, I can just say yes, and you can see the edges is fixed. Or what I can do here is change the direction constraint if I want to. But for now, I'm going to go with 100 and 200 if you want to see and no fixed edges. If you want to make a deformation on the base surface, for example, like this, and maybe I can just decrease the height if I want to make it a little bit better. Okay, now that we have the base surface, we can bring it into Grasshopper. To make this tutorial as easy as possible, I have turned on these as icons, and also I have activated the draw icon and draw full names, and also the bifocus plugin so you can see the commands. So remember that you can turn this on if you want to see exactly what you can see in this tutorial. What I want to do is to go first in the params menu, which is the parameters we want to import, and go with the surface. So we just wanted to bring this into the canvas and right click on this and go with set one surface, because we want to bring that into Grasshopper. So I'm going to import that into Grasshopper, and as you can see, it's going to be highlighted in green. We can internalize this in Grasshopper if we want to. We just have to right click and click on internalize data. So I'm going to just right click internalize data, and we can delete the Rhino base surface. This is going to be inside Grasshopper, and we don't need to save the Rhino file. Now that we have the base surface, let's go and divide it into a series of edges. This is the first step. So if you look at the steps I'm going to take here, first I'm going to divide this base surface into the bottom layer. So if you want to go with the first step is to make the bottom layer. Then what we want to do is to make the top layer, which is going to be this part, and then we're going to make the web layers, which is like these little curves here inside between the two layers, and then we're going to go with the panels, which is the panels you can see here. So let's start and go with the bottom layer. If you want to make a bottom layer, for example, for this surface, the best technique you can use in a Grasshopper is, I'm going to teach you this technique. So whenever you see a surface and you think, how can I produce or divide this surface into a series of lines, and basically use that. This technique is going to help you. First, I'm going to go to the surface and use this divide surface tool. Divide surface is going to actually divide the surface into UV count. So let's just turn this off. And as you can see, we can give this a number slider, for example, 1 to 30. And I'm going to give this to the U and V count, okay? As you can see, by increasing, this is dividing the U division, and this is increasing the V division. This tool is great because it's exactly the output we need. For example, if I just go to the output here, you can see that it has 8 group of 10s, okay? And if you don't know about these groups, you can either watch the video tutorial I'm going to put up here, or you can enroll in our course. We have a complete data management section, which I have explained this in powercourse.com. But for now, to make it as simple as possible, I want to just right click here and simplify this, okay? So I'm going to simplify this because I wanted to show you the groups here. And as you can see this, let me just decrease that into like 3 and 5. When you divide a surface into like 3 count, what's happening is that it's going to give you 4 rows, okay? The reason is that it's acting, this number is going to tell you that we have 3 divisions, okay? So it's going to give you 4 rows, that's obvious. And if you want to divide the V count into 5, it's going to give you 6 columns. For example, this is going to give you 5. That is going to give, the output is going to be actually 6 columns. So you can see it here that we have 4 groups of 6 points. This is really great because what we can do here is to interpolate the input of the groups. Let me explain this with a Param viewer so you can understand it. If I connect these points together, for example, I go to the curve and use this interpolate tool here, what is going to happen is that it's going to run this command, and let me just explain this. It's going to run this interpolate command in each of these groups. So it's going to run it 4 times, right? We want to, actually this means that we want to interpolate 4 times these 6 points, okay? If you want to actually know what's happening behind this, you can also go to display and go to point list and connect a series of points to this, and I usually bake it so I can see the colors, and now you can see it here. Again, this is going to be the first group, and this is going to be like 0, 1, 2, 3, 4, 5. So that is 6. 6 points here. And that is going to help you to, again, make this interpolation, right? So when we interpolate, remember always, if you're a beginner and you want to know what's happening, connect a Param viewer to it and say, I'm saying to the computer that I want to interpolate 4 times, and each time it's going to be 6 points connected to each other. So that is actually what we're going to do it here. And you can see it's going to be NURBS curve. Because we want to make this as a line, instead of using an interpolation, I'm going to go to curve and use a polyline because we want a series of lines, and this is going to be easier and it's going to make it like a real space frame structure. As we make this polyline, because we need actually each of these edges, it's a connected line, we have to explode it. So I'm going to go to the curve, utility, and use this explode tool, okay? So I'm going to use this explode tool, and as I'm exploding this, it's going to give me segments. So again, we have 4 polylines. Each polyline has 7 segments. Remember that I'm explaining these one by one, because this is going to help you to understand what's happening behind everything, why we flatten or graph things. And again, in the params menu, I'm going to take a curve container and put it inside a curve so we can use it for later. The next part is how can we actually, let me just connect that point list here. How can I change the rows and the columns? Again, a technique that when we think about how can we change the rows and the columns, for example, it's going to be 6 groups, okay? Each group has going to go 4, okay? For example, it's going to be like this. This is going to be the first group, and it's going to be 0, 1, 2, 3. There's a great tool in Grasshopper. You can do that simply by just going to the set, which is in the list section. I guess we have to go to the tree because we are going to do that on the groups, and use the flip matrix. That is better. So I'm going to use the flip matrix. And when we flip it, as you can see here, it's going to change into 6 groups of 4. You can also double click this to see the number of groups here if you want to. So as you can see, first it was like 4 groups, now it's like 6 groups, and the rows and the columns has changed their location. So if I just bake that, you can see it's happening. So it's like 0, 1, 2, 3, 0, 1, 2, 3, until the end. That is going to be the fastest way to make a change in the row and the columns. Again, we can just explode that, and sorry, we have to make the polyline also. So I'm going to Control C, Control V. And to make it better, I'm going to make a point container and connect it all to a point. Okay. And again, if I want to bring them all into one curve, I can just use the Shift key and add it up here. And to deconstruct all of these groups, because the group is not really important here, I can just flatten this. Right click and flatten. And now you can see if I bake it, I have each of these polylines easily. And that's how we can do it, okay? This is the tool we want to use later for the top section. We just want to give the points, and then it's going to calculate the curves here, okay? The polylines and the lines, okay? If you want to make this as a tool, the fast technique is to use a Control C, Control V, bring it down. And then in the params menu, there is in the utility and input and output, okay? For example, input here, I want to make a tool to give it a point, and an output, it's going to give us a curve. I just selected. If you use the middle mouse button, it's going to be here, the cluster, or you can just right click and use the cluster. Doesn't really matter, whatever you do. And then you can have this great tool, which is a compact series of components in one component. If you double click it, you can see the tool. If you close it, you can just go back. So if I want to make it easier, I can just get rid of this part and give it to here, and where I will have completely the curves as the output. So that is a great tool if you want to make a cluster and have it in your projects. Okay, after making the bottom layer, now it's time to make the top layer for this base surface. The most important part for here is to find the normal of each of these faces. For example, this face for here, what we have to do is to find the normal direction and then move the centroid in the normal direction. That is going to give us the top layer. For doing that, what we can do here is to use the surface, utility, and isotrim tool. The isotrim tool is really a great tool to divide a surface into a number of UV counts. And the best part is that first you have to give the surface input. So I'm going to give that surface to the isotrim. The domain is actually a domain to input. Okay, that is, let me just type this here. This is a domain to input. And what we have to do here is to actually use a tool called math domain and divide domain to. We can use other tools like construct domain 2, which is going to give us more control over the division. But maybe in the future, if you're interested, just comment below and we will add it in the future tutorials. For example, if you want to just compress the divisions at the start and then open it up. But now, to make it as simple as possible, I'm going to just go with divide domain 2 and divide this surface into a series of UV count. So I'm going to give that surface to the domain. This is going to calculate the domain of the surface. It's not really important because it's going to be anything for each surface, but for now, and then give it that segments to the domain. The most important is that the UV count has to be the same as the UV count of the divide surface. And as you can see here, by using this simple trick, you can have this base surface divided into a series of surfaces. So the last step I have to take is to extract the normal direction from this subsurfaces, and we usually go to the surface command here, and in the analysis section we have this tool called evaluate surface. I'm going to give that to the surface. The most important thing about this one, because I've talked about this in the course, if you want to know exactly and more information about this one, you can enroll in our course, powercourse.com. But for now, what I want to do is to just right click here and reparameterize. That's going to make it from 0 to 1 and 0 to 1 in each direction. And for the UV point, this is actually not a point, it's a UV point, okay? This is a UV point, and a UV point is what it means that if, for example, it just has X and Y, it doesn't have a Z, okay? If we want to make it simple. What I usually use is an MD slider, a multi-dimension slider, which is a double number slider starting from 0, 0 to 1, 1. And if I give that to a UV point, you can see that I can cover any part of this base surface. If I want to extract, for example, the normal direction of here, as you can see here in this small surface, it's going to be different, right? So that is really important to give a proper UV point. If you want to use the MD slider, it's okay, but I also use another technique with 2 forward slashes, a panel, and I just say 0.5, 0.5. This is also going to help us to extract the center and have the normal direction. We also have the point, so everything is ready to move this point in the normal direction. Now let's just move it. From transform, we have this move tool, and we can move this point in the normal direction, and you can see it's going to move it in the normal direction by 1 unit because it's a unit vector, okay, in the normal direction. Now we just have to multiply that with a number. So I'm going to go to the math and use this multiplication. Give it a number slider. That is going to help us to move that point. Let's just decrease the number of the divisions so you can see that. Turn off the surface. This is going to help you to see this point. That is going to move that in the normal direction. I can even increase that. And that's it. Okay, so that was the way we can move the points in the normal direction. Just turn everything off. And we have the top points. Okay, we made this cluster, so we're going to use that Control-C, Control-V for the top, but there's a problem here. As you can see, it's going to just connect everything together. The reason we use this cluster is that when we use this divide surface tool, by default, it's going to give you a series of rows and columns, okay? So that's a great tool. Divide surface is always going to give you rows and columns. But here, as you can see, we just move these points without any group. So what we did here is that when we, so as you can see, these points, if I give that to a Parm viewer again, they are all inside one group. Again, you can just right click and simplify. So as you can see here, so if I connect that to a param viewer, you can see it's just one group of 63 points, which they don't have a row and a column. How can we fix that? Again, let's go to the points. Remember, when you don't know what's happening, the best, especially if you have points, you can go to display and select a point list and bake it up so you can see what's happening. And you can see it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until the end. There is no groups, no data management. And now what we want to do is to put these points inside a series of groups. And again, these points in the second group and these points in the third group, right? How can we do that? The tool that's going to help us to do this is called partition. Okay, partition tool. And we can do that by going to the set. In the list section, you can find it here. Partition list. That means that we want to put these points into series of groups. I'm going to just give that number slider to show you what's happening here. For example, if I just change this number slider, you can see that it's going to put that into group of 8. And because this is not the same of the rows and the columns, you can see that we can get extra points. For example, if I bake that, you can see that it's going to go like this: 0, 1, 2, 3, 4, 5, 6, 7, which is wrong. And what we have to do is to go with one of these number sliders. Perhaps this is going to increase the number of the rows. So I'm going to use this, give it to the size, simplify, and it's okay because we have 9 groups with 5 points, which is completely correct. And if we bake the point list, you can see it's completely in a correct manner. Okay, now that we have these divisions, what we have to do is to just simply give that to the cluster, and we can make the top row, and everything is going to be fine. We just have to change the height to make the component work. Okay, turn everything off. That is exactly what we needed. Okay, now that we have these top and bottom layer, let me just decrease these divisions. What I want to do is to use this moved points and make the webs. The web is really easy. What we have to do is to connect each of these corners to the moved point, right? And actually make it happen. So how can we do that? The webs. The web is to find the corner of the base surface, and I'm going to use the subsurfaces we extracted in the isotrim tool. We can go to surface, and we can just use deconstruct to extract the corners. And here you go. You can see each of them has 4 vertices. I can also simplify that if I just want to show you that. We have 12 base surfaces. Each of them has 4 corners. So this is the number of the panels. This is the number of the corners. Okay. And what we want to do is to connect a line from these vertices, the corners, to the moved points. Not the partition list, because remember that we made that partition list because we wanted to divide it into a series of rows and columns. We wanted to connect that to here. But what's going to happen is that it's going to connect everything to everyone. And here again, the reason is that we don't have the right data management or the grouping of the data. Again, if you don't know about this, you can watch the free tutorial I put in the cards up here, or you can go to PowerCourse and watch the complete data management section we have in our course. But for now, I'm going to give you a trick, and here let me just show you what's happening. Let me just make this like 2 and 2 to make it as simple as possible. You can see it here. Okay, we have 4 surfaces. Each surface has 4 corners, and we have also the top layer, which is in one group. What's happening is that Grasshopper is going to think, okay, the group are not the same. What should I do? It's going to go with this first group for the first group, and then the rest of the group don't have any data. Okay, so what it's going to do is it's going to again just run it all till the end. To fix this, what we should have here is to have the same data management here, but the n has to go like n equals 1. Okay, each of them has to go in one group. That's really easy. What I want to do here is to graft this points. And you can see it's fixed. We have 4 groups of 1. Again, a technique you can always use, if you have all of your data in one group, you just graft it. And when you graft it, each of these data is going to go in one group. So that is the technique. Just graft it. And now when we increase the number of the divisions, it's going to be okay. And we will have those webs. That is making the webs. So the next part is to make the panels. Okay, to make the panels, I'm going to make this as simple as possible because I don't want to overwhelm you, especially that Grasshopper is already complicated. But for now, what we want to do is really simple. We just want to convert these free form surfaces into a corner surface, right? We just want to make that like this into a 4-point surface to make it a simple panel. Just a disclaimer, if you want to know, a 4-point surface is not always flat because it could somehow, for example, if I just move this point a little bit up, you can see it can be a saddle-like surface. And obviously it's not always flat, but a 3-point surface triangle is always flat because 3 points are always in a plane. If you're interested, just ask below. Maybe in the future I'm going to put a tutorial on how to planarize polygons like this. But for now, what I want to do is to make it a technique to make it planar, and that is to make triangles like this. So a triangle at here and a triangle at here instead of this surface, right? And obviously that is going to give you flat surfaces, and you're not going to worry about is it flat or not. Let's get started and give that to here. We have this isotrim, give it to a surface, and explain it on how we can convert that into a triangle. The best technique I have found is to simply use a mesh with a triangulation. That is going to be the fastest way. So I'm going to go to this mesh tools, and in the utility, whenever you have a triangular or a quad, always you can use this simple mesh tool. Okay, a simple mesh is going to help you to convert that into a 4-point surface tool like this. That is really, really easy. And another tool you can use combined with this simple mesh is triangulate. Triangles here. You can see that you can have the triangles. That is the fastest way you can make the triangles on a quad. But what if we want to change the directions, and as you can see, one is like this one is in another direction. This one is going to use another advanced tool, and that is to go to this isotrim tool surfaces and explode it, deconstruct brep as we used it before. And as we talked about this before, we had 4 corners. I'm going to go to this set and list item. This list item thing is going to pick up things, pick up the items. For example, the index is 0. It's going to pick up the first vertex by moving and adding up. It's going to extract all the 4-point surfaces we have here. This is a great exercise if you want to make a quad or a triangular surface in NURBS. So I just want to go to the surface, and if I want to make a 4-point surface, I can go to here, the free form. If I connect all of those 4-point vertices, we're going to have this quad NURBS surface. It's not a mesh, it's a quad NURBS, and a quad NURBS is not always flat, remember that. So what we can do here is to play with these corners. We just turn off everything. So let me explain what's happening here so you understand it better. I'm going to just list item one of the faces here. For example, maybe 0, 1, 2, 3, 4. And deconstruct it and give it a point list so you understand what's actually happening in the computer. And you can see it here. Okay, we have like 0, 1, 2, and 3. That is the number of the corners. And by using this list item tool from the vertices of 4 with index 0, it's going to extract the index 0, index 1, index 2, and index 3. When we connect like 0, 1, 2, it's going to give me this triangle. Now what I need here is to connect 2, 0, and 3. So I'm going to also make another 4-point surface. We can go like 2, 3, 0. 2, 3, 0. And here we have those panels. That is really easy. And that is how we can make the panels a triangular panel in Grasshopper for the space frame. Okay, now that we have made all of those things, let me just increase the division. We made the UV division. We moved them in the normal direction. We made those panels. It's time to visualize them. The last trick I told that if you watch this video till the end, we're going to talk about it. Perhaps it's a long tutorial, but for those who are interested, what we can do is to visualize this really fast. I have some tutorials that I've talked about giving it a pipe or a sphere at those knots, but here what you can do is to use a quick trick in display. In the preview, there is a thing called dot display, and what I want to do is to give these points. I guess one of the points is like here from the division from the bottom, and one was before we made the partition. So I'm going to use the shift key to add it to the input. Use a swatch, SWAT, just for a quick search. I usually delete the title and give it to the color. Black is fine. And the size is actually a sphere, but it's not a sphere. It's just, I don't know, maybe a mesh or thing that it's rendering really, really fast. So that is going to help you to increase the numbers really fast without getting into visualization. If you want to, you can go to sphere, for example. We can just give that those points a sphere. For example, this one with a radius, but okay, it's going to be a little bit slow. The next trick I want to show you that is you can use the human plugin. So I'm going to put it up here. It's the human plugin. And by going to display, you can use this custom preview line weight. So I'm going to use this custom preview line weight and give all the curves, the top, the bottom, and the webs to the input. And remember that you have to just turn everything off. And in the absolute, because it has to give the absolute thickness, as you can see, it's set true to try render curves with an absolute dimension. I'm going to just invert this so it's a complete absolute. So I'm going to give that a thickness and again a color. Okay, that is really fast compared to a pipe thing. And that's how you can do it. Okay, that is really great. Now we just have to visualize the panels. We can go with display and use this custom preview tool. Use the shift key. Maybe if you want to have different colors, you can use two different custom previews. One for one of the triangles, just get rid of the title, make it smaller. And okay, so now you can see that we can give different colors to this. For example, this two colors if you want to see it. And just for visualization, if you want to, you can also just simply right click on this and change the transparency a little bit. So it's just a little bit transparent. And as you can see, it's getting better for visualization. Just to show that I'm designing this, this is going to help you to change things really fast. And as you can see here, I can change the divisions, the number of the UV rows, the height, and also if I want to, the visualization can be really easy to see the final results. Also, if you want to download a simplified version of this tutorial, the example file, you can click the link below. It's available for our premium members and they can download it and just take a look so they can understand this easier for future practices. Okay, thanks for watching. Remember to like and share this video. I hope this was useful. If you have any comments, ask below. We will try to answer as much as we can. And be sure to subscribe to this channel and share it with your friends. Thanks for watching. See you next time. Bye.